All right, Dr. Ethan Siegel, thank you for coming on. Ethan Siegel is an astrophysicist, science communicator, and writer. He earned his Ph.D. in astrophysics from University of Florida and went on to do research in the field of galaxy formation and evolution. He is currently a professor at Lewis and Clark College in Portland, Oregon, where he teaches physics and astronomy. He's also known for his popular science writing and his ability to communicate complex scientific concepts to a broad audience. He's the author of several books, including Treknology, the Science of Star Trek from Tricorders to Warp Drive, Beyond the Galaxy, How Humanity Looked Beyond Our Milky Way and Discovered the Entire Universe. And he also writes a blog called Starts with a Bang and is, I believe, a senior contributor at Forbes and on NASA's website. I get everything right?
It was pretty close. I don't teach at Lewis and Clark anymore. That was a job that I actually left. I last taught 8 years ago there. And I moved from Forbes in 2021 to Big Think, which is now my main writing home on the internet. But other than that, you got everything right. And this is pretty good. I'm excited to be here and to talk to you about everything we're interested in about what's going on out there in the universe and how it relates to what's happening here on Earth.
Yeah, sounds good. And Big Think even better. It's an upgrade, I think. But yeah, so maybe we can start off with some of your present research interests and where the cosmological research is today, and we can see what comes up.
You know, my favorite things about the frontiers of what we know is how they're being pushed back in a whole bunch of different ways. Most of us learned, oh yeah, we know where the universe came from. It started with this hot Big Bang and evolved and expanded and cooled from there, and also gravitated and formed stars and galaxies, and that leads to things like the Milky Way with its stars and planets, and even sometimes things like human beings on those planets. Um, but modern cosmology has actually taught us that the Big Bang itself wasn't the very beginning. It was preceded and set up by a different phase known as cosmic inflation. And cosmic inflation is now the earliest thing we talk about in the universe, and how the Big Bang came only as the aftermath of that state. So that's one huge advance that I think is tremendous that a lot of people don't appreciate. Another is that you say, okay, well, look, we've got an expanding universe that starts off at the Big Bang. And as the universe expands, it also gravitates. There's a bunch of matter and energy in it. And we thought, oh, well, maybe there are three possible fates. Either the expansion will win and there isn't enough gravity, so things will just expand forever. Or there is enough gravity and it'll expand and then it'll recontract and boom, end in a big crunch. Or maybe it's like Goldilocks and the Three Bears, right? It's neither too fast nor too slow. Maybe it's right in the middle where it'll asymptote or approach some maximum value, but it'll never recollapse, but it won't also go off into oblivion. And one of the things we learned recently, like within the last 25 years, is that it's not doing any of those. It's like it was in that Goldilocks case, and then all of a sudden, for some reason, these distant galaxies started speeding up faster and faster, moving away from us. For some reason, the expansion of the universe is accelerating. So these are some of the frontiers that I'm really interested in. And one that's opened up very recently has sort of happened with the James Webb Space Telescope, where we're asking the question of not just how did the universe, like, where did it come from and what's its ultimate fate going to be, but how did it grow up? How did it grow up from this early hot dense state with no stars or galaxies to the very first stars and galaxies? And with the James Webb Space Telescope, we're seeing back farther, earlier, to the most distant stars and galaxies we've ever seen. So these are I think the three frontiers that I think are the most exciting right now.
Yeah, they certainly sound exciting, and I don't even know where to start necessarily. This view that the Big Bang was not, in fact, the start of the universe, but there was time and space that preceded it. Is this something that has found consensus in the present kind of physics community, or is this a new theory that is on
Well,
the fence?
so I'll say, if you ask for consensus, like what percent of physicists does it take to get to a consensus? Because for me, I look at three things. I don't look at what people say, right? Like polling people. We don't do science by democracy. We do science with evidence. So I'll say if the Big Bang is your old theory, if you have a new theory that comes along and you want to compare it to the Big Bang, that new theory has to do three things. Number one, everything that the Big Bang was successful at, this new theory also has to be successful at. So if you say the Big Bang explains why we have a leftover glow of radiation in all directions, my new theory better give you a leftover glow of radiation in all directions too. If I say the Big Bang explains why we have no stars and galaxies, and then primitive stars and galaxies, and then more evolved stars and galaxies as we come up to the present day, my new theory better give you that too. And if I say the Big Bang gives you a universe that's roughly uniform in space and the same in all directions, my new theory better do that too. So the first step is you've got to reproduce all the successes of the hot Big Bang. The second step is you can say, well, look, if I just had the Big Bang, if I just went back to a singularity and said everything came out of that, I would say, okay, well, there are some puzzles that the Big Bang can't explain. Like if I say the universe began with the Big Bang and now it expanded, and there's a maximum distance I can see in that direction and a maximum distance I can see in the other opposite direction, why would these two regions that have never had enough time for light to go from one end to the other, why would they act like they had the same properties? Why would they act like they had been in contact and had come to equilibrium some point in the past? That's a puzzle. Big Bang can't explain that. I can also say, why does the universe look like it's in that Goldilocks case? Why does it look like it's not recollapsing or expanding into oblivion? Why does it look like the expansion rate and the total amount of stuff, matter, and energy in the universe, why do they balance so well? But the third thing that always puzzled me the most is we know that the stuff in the standard model of particles, isn't all there is. We know at some higher energy, at some point, you should be able to start making new exotic particles beyond the standard model. But the hot Big Bang, if it got all the way up to like infinite arbitrary temperatures and energies, it should have made all those things. It should have made all those super high energy things. So where are they? Why does our universe not have those? So if your Big Bang doesn't explain that, your new theory, you want it to. But even that's not enough. Even if you reproduce all its successes and you explain things it can't explain, you still have to go to that third thing, which is I need to make new predictions from this new theory that differ from the Big Bang's predictions, that I can then go out and measure, is it the new theory or the Big Bang? Who has it right? That's what you have to do. You have to do all three of those things if you want to overthrow a scientific theory. Well, cosmic inflation was put out in the early 1980s, and it was put out originally because someone figured out, it was Alan Guth, who's at MIT. Alan Guth figured out, I can do step two. These things that the Big Bang couldn't explain. If I said the universe started off in an inflating phase where inflation says instead of matter, the universe was filled with a form of energy that was inherent to space itself. So over time, the universe would double and double and double in all three dimensions. And then when that same amount of time passed again, it would double again and double again and double again in all three dimensions. And so after only if one of these doublings takes a fraction of a second, then after 100 fractions of a second, I've gone from something that's smaller than the Planck scale, the smallest scale at which physics makes sense, to bigger than the visible universe. So that's why things in different directions can look so similar. That's why things are going to be perfectly balanced between expansion and energy. And that's why we don't have these high energy relics left over, because after inflation ends and the Big Bang happens, we don't go up to infinite temperatures. We only go up to the temperatures at the energy scale of which inflation occurred, which can be thousands or more times lower in energy than the Planck energy. So then in the early 80s, people said, oh, well, we can figure out how to make inflation do that and also reproduce all the successes of the Big Bang. So that was called the graceful exit problem, and they solved that in like 1982 or 1983. Then they said, well, let's also make new predictions. So in the 80s and the early 90s, they said, oh, well, you also have quantum fields throughout the universe. So as your universe inflates, these quantum fluctuations should get stretched across the universe, and these should create the seeds of cosmic structure. So when we go out and we measure stars and galaxies and imperfections in the leftover glow from the Big Bang, we should see those patterns predicted by inflation. Big Bang's pretty agnostic about all that stuff. So that was how we took that step. And people who work in cosmology overwhelmingly accept inflation because it's done those three critical steps. We've made 4 new predictions that contrast with the Big Bang's 4 predictions for what these fluctuations imprinted in the universe should look like. And inflation's 4 for 4, and Big Bang without inflation is 0 for 4. Now, I won't say that gives a consensus, because not everyone is convinced by that, right? You can always have people who say like, oh, well, no, those 4 tests didn't matter. I want this 5th test, and that'll be the critical one. And we haven't been able to test that yet, so I'm not convinced. But I'm not here to convince all the naysayers. I'm just here to follow the evidence. And for me, 4 for 4 versus 0 for 4, that I picked the better theory. That's it. So I would say working hypothesis, inflation first, that gives rise to a Big Bang in the aftermath, is something that most working cosmologists accept, even if not everyone is happy with it.
Yeah, no, those are a bunch of great points, right? It has a winning record from what it sounds like. I think that could lead us into a little bit of discussion concerning how we, in fact, come to a knowledge of the universe, right? I think a really salient concept that has been discussed, for example, by somebody like Pierre Diom, if that's how we pronounce his name, is saving the appearances, right? We have a bunch of appearances, a bunch of sense content, and then we need to come up with a system that can, so to speak, save that sense content, meaning to intercoordinate it mathematically to make predictions as to, say, where a new planet will be and how we're going to perceive certain things and certain test results and such, right? And we can consequently construct a certain mathematical world image from taking measurements from our sense contents, and then from that world image we can make deductions, and then we can think about what observations would amount to those deductions, for example, via correspondence statements, right? And then if observations line up with those deductions, we say that the given mathematical world image is true, right? Whether it's the Big Bang or the cosmological model or what have we. Yet some philosophers of science would say that that would never, on principle, follow, because all that we have are the appearances and simply different ways of saving them. For example, whether it's Euclidean geometry or any of the other internally consistent systems, we're saving our appearances. But it's not to say that that system, that series of signs and symbols and mathematical terms, right, and also regular plain terms to describe some of those equations, that is literally so in some kind of fundamental way. You get what I'm
Well,
saying?
I think you bring up a really good point here, because there's a big difference between saying this is a model that describes reality versus saying this model is reality. And
Mm.
I think you have to be pretty careful with that as scientists to recognize, look, any theory we're ever going to come up with is only going to be an approximation of reality. We even though we talk about things like scientific truths, we're not saying this is the absolute truth of what reality is, right? Newtonian gravity is an incredibly good description of most of the gravitational phenomena in the universe. You can explain why the moon orbits the sun, why objects fall down on Earth, why the planets of the solar system have the orbits that they do. But it's not a perfect theory. It only has a range of validity to it. If you move too close to the speed of light, Newtonian gravity doesn't give you the right answer. If you go too close to a large massive object like Mercury orbiting the sun, Newtonian gravity's predictions are gonna be slightly wrong. They're gonna slightly deviate. So you can come up with a better approximation of reality that's more successful, like Einstein's general relativity. But that doesn't mean Einstein's general relativity is true. It means it's a better, more successful approximation of reality. But just like I could have asked questions about Newtonian gravity that it can't answer, I could ask questions about Einstein's general relativity that it can't answer. Like, hey, let's say I have an electron and I do a quantum experiment. I have a double slit experiment. I know quantum mechanically, if I send that electron through a double slit and I don't watch which slit it goes through, I know that electron is going to make a wave pattern that interferes with itself as it goes through the slit. And then it's going to wind up on a screen behind that slit at some point, determined by a probability distribution. What I don't know is what happens to the gravitational field of the electron as it moves through the double slit. Does it act like the electron is a point that moves through one of the slits and that's what its gravitational field is? Or does it act like an interference pattern, a wave pattern that makes an unusual gravitational field that's different from my experience? Well, general relativity doesn't give you an answer. It doesn't know. So I know because I can formulate a physical experiment in principle that I don't get a straight answer from. I can say, I know that general relativity too has its limits. It has its limitations. So I shouldn't pretend like this is some absolute truth. I should recognize and be aware of what are the limits of my theory. Sometimes we extrapolate a theory beyond its limits and we discover, wow, it's still valid. Funny that. Sometimes we extrapolate a theory beyond its range of validity and find, oh, no, this conflicts with what we saw. And sometimes when we think a theory should still be valid, we see something in there that surprises us. And that's my favorite thing. That's my favorite situation, because that is usually the harbinger of, ooh, we're about to discover something really fascinating and have that next big breakthrough.
Right. Yeah, those are great points. I think it's the point has been made, funnily enough, that say the some of the appearances concerning the planets and the arrangement of the solar system and the universe can be saved, so to speak, equally well by the say Ptolemaic system as by the Copernican system. So we can't say, in fact, what are the say the realities concerning the rotation of the sun and the Earth. It depends how we look at it, but it's more convenient to assume that the planets do center around the sun, as I understand it. Right, but also speaking about the overthrow of different paradigms, I think the point has been made that it's more so a psychological factor, because if I insist on remaining within the domain of a given paradigm, I can always move things around in order to continue to save the appearances, right? Observations themselves are, so to speak, theory laden. It's not that they're just raw kind of sensations that prove or disprove a theory, right? It's here's a sensation. But the observations already are made, if they're sufficiently complicated, in light of theory, right? I guess we can say, blue is not theory laden, blue, red, up, down, but any more sophisticated measurements such as quantum ones and all of that. So consequently, if, say, I insist on, again, remaining within the perimeter of a given paradigm, I'll remain there no matter what the evidence may be. Right? I think that's a point that Kuhn made in his book, Scientific.
The
What is
structure
it?
of scientific revolutions,
Structure of
right?
scientific revolutions. Only when there's a new paradigm that is sufficiently appealing and alluring, right, and a new generation of scientists is drawn to it, that gives hope for that kind of change. But it's not likely to happen while people are committed to the present paradigm, is a point I believe he made.
Yeah, although I do have to say I've been very pleased. The discovery of dark energy, for example, is something that was a big surprise. Before the 1990s, no one was really considering that we would live in a universe that would have not only some sort of energy inherent to empty space itself, but that would be the dominant form of energy in the universe. And during the 90s, teams of people, mostly working with ground-based telescopes, started observing distant supernovae. What the great thing about observing something really far away is its light has to travel to you. And the farther away it is, the longer it takes to get there. And because the universe is expanding, the longer it takes to travel to you, it undergoes all of the cumulative expansion of the universe. Remember, light has a specific wavelength, and that wavelength determines its energy. So as the universe expands and stretches, that wavelength of light gets stretched along with it too. So the big idea is that by observing objects farther and farther and farther away, we're getting this view of, okay, how did the universe expand between these points and these points and these points? We can build up what's the cumulative expansion history of the universe, and that's sensitive to what's in your universe. What species of energy do you have? Is it just matter? Do you have matter and radiation? Do you have matter and radiation and spatial curvature? Do you have matter and radiation and some sort of dark energy? Well, I was very pleased. The first evidence for dark energy only was published in 1998. And by 2004, just 6 years later, everyone had accepted it. The evidence was so good that this didn't take generations of people being wedded to, no, it's only matter and radiation, there's nothing else. No, people changed their mind really quickly, including almost all the experts in the field. And that was like a remarkable thing to not just see, but to live through as an academic. So I think that when the predictions are clear, when the predictive power is clear, when you have multiple lines of evidence to investigate a claim for, and they all point towards one solution and not the other, I think that type of progress can happen very quickly, especially in today's world. We mostly, look, you can always find people who are resistant to accepting new evidence. That doesn't interest me as much as what's the community doing, right? The scientific community working on this all says, oh, we used to think this, but then we saw this, and now we think this. That's very compelling to me. And I'm really pleased that I think if Kuhn were alive today, he would be very impressed at some of the ways that science has advanced in a very short amount of time, because it hasn't taken generations of people to overcome some sort of dogma. No, we're actually pretty good as a community at following the evidence, even if it leads us into pretty uncomfortable places.
Yeah, no, that's a great point that it doesn't always take the old guard dying out or something for new views to become preeminent, right? And people are able to follow the evidence. But I think there's a deeper theme here, right? All of this, this kind of discussion presupposes a positive view of, say, what's been called scientific realism, right? That the terms of physics, for example, are correspondent to uh, concrete realities. For example, terms such as atoms, terms such as matter, terms such as energy. But of course, there is a negative view of scientific realism that has certainly had great exponents like Ernest Mach, for example, Poincaré, perhaps, that would say that view that these terms do not correspond to real entities and cannot do so in principle, given that we always start off with our sense content, which are objects and appearances to a subject. And we can never, on principle, jump to a world image that we claim is really concrete and really putting the cart before the horse. So, for example, just to get the point, let's say that Einstein falls asleep or somebody of like caliber, right? And he has a dream, and in the dream, things follow different rules, right? You throw a ball and it goes that way, right? It goes diagonally, it goes up, something like this. So he makes measurements, or she, Lisa Meitner or somebody like that makes measurements and creates the equations, and then says, okay, this is the nature of the universe, right? Everything is made out of atoms and the laws of physics. Isn't it? Doesn't it seem quite clear that that would be a fundamentally, philosophically untenable jump to go from appearances to the subject to supposing absolute reality or concreteness to a mathematical description of those appearances?
I mean, I agree with that. Like if all of what we perceive as reality is a dream, that our senses are unreliable, our measurement apparatuses are unreliable, that we might not be talking about reality when we think we're talking about reality. But I've always kind of had the same line of thought that Heisenberg had about it. Because Heisenberg, one of the founders of quantum mechanics, and the big thing he's remembered for is quantum uncertainty, that there are certain fundamental combinations of properties that you can't know simultaneously. We like to say things like, Jeremy, if you give me your coordinates, like your three-dimensional coordinates in space, and now this moment in time, you can pinpoint here's exactly where you are. And if you tell me like how fast you're moving in all three dimensions, you can write down like, oh, and this is your velocity vector, this is how you're moving through that space. It turns out you can't do those two things simultaneously exactly. There's always some inherent uncertainty to it. That was Heisenberg's big contribution to the
Only in
world.
the quantum realm, or even in
Well,
macroscopic?
it starts in the quantum realm, but it means there's any uncertainty, even to macroscopic objects, even though it might be small, it's still inherently uncertain. Like that's a fundamental part of its reality. But when Heisenberg talked about reality, he never talked about what's the thing doing when you're not measuring it. He only talked about, he didn't talk about an objective underlying reality. He was like, that is an assumption that we can't say anything about. But what I can measure, what I can detect, what I can quantify, what I can, you know, when I have an interaction and I know this and this were at the same place and the same time, and they ran into each other, and I measured how they went off from each other, that's real. We can't be sure that everything is real, but at least as confident as we can be that what we experience is somewhat related to whatever real reality exists. What you measure and observe and detect, that's as real as it gets. Now, I can't promise you that it's actually all real, right? I can't tell you that that sometime after we all die, we won't wake up from what we've experienced as our reality and find, oh no, all of this was some, invention of, electrical chemical activity or something, that we just hallucinated all of this, that none of this is real, that atoms aren't real, that this is just our flawed perception of what's actually real. That's not something I can speak to. That's always possible. But in as far as we can say our measurements are reliable, our instruments are reliable, our senses are reliable, our measuring devices are reliable, that's the only context we have to work in to do science. So, you know, whether it's true or not, uh, it seems to give results that successfully predict observed behaviors and can successfully predict the future behavior of a system if we know its initial conditions and these rules that science has found for governing them. That's a success to me. Whether it convinces you or any of your listeners that this is the answer or that adds up to reality, I can't speak to that. But for me, I'm happy to say, when I say here are some laws, here are some rules, here are some, ideas we have for what it derives, and if you measure this and measure this and measure this and follow these rules, then to the best of your knowledge what the end state of your system is going to be. That's the predictive power that I look for in a successful scientific theory. Questions like, is this real or is this not, are interesting to ponder, but they don't either take away from or add to that predictive power.
No, those are some excellent points. I think I would say to your points that there seems to be indisputable that uh, the world system, whatever that in fact is logical. It's internally coherent and consistent. And as for the claim that life is quote unquote a dream or something is false, well, something is false relative to criteria which we deem to constitute something being real. So, for example, if I go to a science museum, as I recall once doing, I see a spoon that looks perfectly real. I reach out, it's a hologram. Say, well, it's a
Right.
fake spoon. Well, it's fake vis-a-vis the criteria of reality, such as would have it have a tangible extension and the capacity to eat with it and so forth. There's nothing fake about uh, the hologram in itself. It's a real holographic spoon, right? So when somebody says, "Oh, I think things are not real or things are a dream," well, what criteria are you providing for reality that life does not meet, right? That the phenomenal world does not meet. It's as real as it is. It's exactly real per the criteria applicable to it. I think, however, a somewhat more subtle point would be that we have the small, which is not quite so small factor of ourselves, as selves and as purportedly or possibly sentient beings, and we have to fit ourselves into the picture of reality, whatever that would be, the cosmological picture, the ontological picture. We have to fit ourselves into there, and if we do take a strict positive view of scientific realism, for example, right? If we do insist that um, some of the terms of physics do correspond to reality, or they are the preeminent way of understanding reality, like you mentioned, then that may create issues for fitting ourselves as sentient beings that hope for a future and have fears and dreams and desires. That may create problems for fitting us into that picture, right? We want to believe that it's possible to conserve certain values in the economy of the universe, so to speak, that it's possible to say that some things are right and some things are wrong, and that perhaps there's purpose to or endless activities, and yet a particular picture of reality would seem to preclude that on principle. You know what I'm saying?
I mean, I think you have to be careful, right? Like, is this a real pen I'm holding up, or is this a light map of a pen that I'm holding up? Unless you can interact with it or not interact with it, you can't know for sure. And and for me, I also think, like, at some point, we're gonna say goodbye. I'm gonna turn off Zoom, and for you, maybe I cease to exist. Maybe I only exist for you while you're interacting with me. And when you cease to interact with me, do I keep existing independent of that? Does anyone else exist in the universe, or is it just you? Right? This is solipsism, right? It's not disprovable, but it is something we assume is not true. We assume when we build our pictures of reality that the laws that govern reality are the same everywhere and every when. And we assume that, well, we have such similar biologies to one another that if you have consciousness and sight and senses, that I probably do too, and so do all the other humans on the planet. That we have these commonalities to one another. And that includes common experiences, just like we assume the blue you see and the blue I see are similar or identical blues to one another. But we've never been able to do that experiment. I've never been in anyone else's brain and seen, oh, when I see a rainbow, do you see the same rainbow? When I see orange, do you see orange? When I taste a plum, do you taste the same things when you taste a plum? I mean, we don't know. We don't know because we only have experience being ourselves. And I think these are fascinating philosophical questions, but if you want to do science on the world, you have to start somewhere. And that starts with the assumption that reality, even if it's not what it appears to be, but there is some reality at some level that we can approximate its existence in. And so far, it seems to be successful. The enterprise of science, I mean, if science were not a successful enterprise, we wouldn't keep doing it. There would be no reason to keep doing it. We could do something as equally unsuccessful and get the same
Probably the
results.
most successful movement of thought in human history. I think
I would say
Whitehead
so.
might have
I would
said
say
that.
so. When in another 1,000 years, no one might remember any of us. They might not remember even like Einstein and Newton and Maxwell, and they might not remember the greatest minds in history. But if someone were to come along and do the same experiments, make the same observations, they could draw all of the same conclusions about reality. And the laws should be unchanged and the rules should be unchanged. And that's kind of amazing about science. I can't think of any other human endeavor that I could say that about.
Yeah, that's an excellent point. And again, I think few would dispute or should dispute that uh, scientific thought, thought of under kind of a large umbrella, has certainly been one of the most astounding and useful movements of thought, again, that we've ever had. Right. But I think just to circle back to that point, first of all, something like solipsism, I think, is in fact disprovable because we may kind of have a mismatch of what it means to be oneself. And then that question comes about, does anybody else exist? Right. So what's the proof, for example, that this body exists? Well, because I can touch it. What's the proof that other bodies exist? Well, because I can touch them. What's the proof that the sight of yourself exists? Well, you can look in the mirror and see it. What's the proof that the sight of myself exists? I can look in the mirror and see it. You can look at anybody else, and every face, sight of a face exists, and so far as it does exist. Now, how do you find out about the existence of other minds? The same way we find out about the existence of our own minds, right? Without thinking, without talking, without writing, I have no idea what's inside of my head. Right? I have to get to know myself like I would anybody else. So the proof that my mind exists is on the same epistemological footing as that anybody else's mind exists, that my friend's mind exists, that the mind of transcribed in some text, say from ancient times, exists, and so forth. Now, the sentience itself, like so to speak, stripped of personal qualities uh, that may not be kind of we can suggest we can think that it is an epiphenomenon or excretion of organic tissue, in which case, how do I know that it exists? But we can say it is what it is. It's of a unitary quality. And when I see myself as a subject in you or in somebody else, I think that's the foundation of human love and connection and care, right? If another person is, to me, fundamentally an object, a thing, right? Just a conglomerate of atoms, I cannot and should not care about them, right? We say Chat GPT, for example. It sounds very intelligent, right? But I know in my mind that this is just a thing, that this is just a system of whatever it is, logic gates, the computers, the magnets. So if I say Chat GPT, I love you, I care for you, justice for Chat GPT, that would make me nuts, right? So
Right. I mean, that's the same as saying like, I love you, predictive text button on my phone, right?
right.
That's all Chat GPT is. But this assumption you're making that I am real, that I'm a real person with real thoughts and real uh things that I'm formulating in real time as I interact with you, you can't prove that it's not a complicated illusion. You
Well, it
have
wouldn't
to at
seem.
some point, you have to at some point accept that as an assumption. Like I would say one of the words I use as a scientist, because I'm a physicist, not a mathematician, is I don't prove things. I convince myself. I convince myself and others that these are true. And I think from a philosophical standpoint, it's sort of the same thing. Like, I could always do exactly what you said about saving the appearances. If I insisted yours is the only mind in the real universe, I could keep saving those appearances by concocting new hoops that reality jumps through to create this complicated illusion for you.
Mhm.
And it might be something where at some point, you and everyone else on earth is going to say, Ethan, that's absurd. That's absurd. That can't be right. But you can't prove it. And that, I think, is where sort of I stand on all the issues about reality is, no, like there is a limit to what you can prove and establish. But that doesn't mean it's not useful to make those assumptions and work as though those assumptions have some truth behind them.
Yeah, for sure. And I think that's an excellent point, right? You can, if I really am insistent on solipsism, I can go and try to create any kind of cookie system. I can say I'm in the matrix, this and that. But just briefly, I think the point does hold that if I properly think of oneself and one's components, again, I know for a fact that your face exists because I see it, and it exists in the same way that my face exists, and your voice exists in the same way that my voice exists. Right? And your mind exists in the same way that my mind exists, insofar as it's an inference from the empirical to a cause sufficient to produce that empirical content, right? So,
Right.
and
But
again,
so much of what you've talked about is how much can we trust empiricism? Right? How much can we trust empiricism that this is giving us an accurate picture of reality? To a third party observer, someone looking at us and listening to us, we might seem equally real to one another, but to them, they're only going to have their own internal mind to listen to, telling them what is and isn't true for them. What's going on in my head, I might not. They might say Ethan doesn't have any thoughts. He's just an automaton. Jeremy doesn't have any thoughts. He's just like Max Headrooming this. He's parroting whatever he's been programmed to do. I'm the only one with real thoughts. Now, I don't believe that. I don't think you believe that. I don't think most of your listeners believe that. But that's also similarly, and you have to accept some sort of assumption that I exist and you exist, not just only Rene Descartes exists because cogito ergo sum.
great, yeah, great point. Yeah, I think right, we do start with an understanding of our own existence. How do I know that I exist? How do I prove it? Well, because I just do, right? And even if I was in a
It's pretty
sensory
self-evident.
deprivation
You
tank,
think you think your own existence is self-evident. The existence of others is not
my
self-evident. It's evident.
right, but myself, it depends what we mean by myself. I don't know. Just like Descartes kind of tentatively played with the idea. I don't know that myself in the capacity of a face or of a body has absolute existence. In fact, I know it doesn't, because once the body was a baby body and one day it'll be gone. So it's myself in a different way, myself in the capacity of, say, sentience or something like that, or self consciousness. Now, me coming to terms with myself as a sentient, rational being, I think, then permits me to infer the existence of that same reality as it concerns other eligible objects. Not ChatGPT, not a robot, not a bicentennial man, not a mannequin at the mall, but organic creatures, right, such as possess the same qualities that oneself has. So I can tie in my own sentience, my own ability to feel pain and pleasure with a particular appearance and organic organization. And when I see that in other instances, the only, I believe, proper inference is to say that there is a real person just like me, and that permits, again, I think, that love and connection with others. And as for the insistence on saying, well, no, only I exist, that can also lead us to a good point, which would be that I think human development is predicated on, or healthy human development is predicated on, so to speak, coming up out of oneself, overcoming one's own selfishness and psychology and private idiosyncratic kind of or just private idiosyncrasies. And that in turn demands a worldview that makes that logically feasible. And if we do stick solely to the world of atoms and Higgs boson particles and the laws of physics, then, and we're truly committed to that, not just in talk, but also in feeling, then it would seem that we cannot possibly really progress ourselves as human beings, because our world image does not have that possibility built in, if you get what I'm saying.
I'm not sure I do, because for me, those two questions, they don't necessarily seem related to each other. For me, I know that 7 years ago, the version of myself that existed had somewhere like far less, like a tiny fraction of 1% of the same atoms. The atoms that were in my body 7 years ago, today, fewer than 1% of those same atoms are still in my body. And yet, I still think of myself as the same person, even though I've changed and I've grown and I've aged and I've progressed in some ways. I know that even though I still have that same, I don't know what to call it, me-ness to existence, I know physically I'm not identical. Physically, most of me has been replaced, but I'm still me. I feel like I'm still me at any rate. I like the tests I can do show like it's very similar, like 7 years and 99.9% of my atoms having turned over. I'm still very similar to how I was 7 years ago. And I'm sure you and everyone else listening feels the same, but that doesn't mean that other people aren't as equally deserving of compassion and kindness and love as I am. And I think that, that's sort of independent of what you think of as what's real or what's not. Is we have to be kind to each other for all that we know, for all that we've learned, for all that we've discovered. There's no evidence that anyone is coming from anywhere else to save us from ourselves. In all this universe, we only have one another to be kind to.
No, that's beautifully said, man. I would say, that is a view that we hear sometimes, that it may be that the world is simply, in reality, is simply constituted out of matter, and the person is nothing but a brain, which is nothing but atoms, and yet we should still be kind and loving and just and so forth, and strive for peace and human rights. I would kind of tentatively and modestly suggest that maybe that's a contradiction, right? And it would come from not really being sincere about our views. Again, how I treat a stuffed animal, if I had one, let's say, is certainly should be in light of what I believe the nature of the stuffed animal to be. That's why a little kid that baby's a doll, right? You say, oh, it's a little kid, no problem. If I'm an adult and I think that my child is my doll, that means there's something, some marbles are loose, right? Because the nature of what is being dealt with should direct our treatment of it. So if I
Right.
really, truly, sincerely, earnestly am a subscriber of, say, what would we call it, dogmatic naturalism or something like that, for example, right, then I don't have the room, it does seem to me, to say that I still believe in love and kindness and human rights, because I and everybody else are just conglomerates of stuff, and stuff is stuff, right? I do still feel a little
Yeah.
pain and pleasure temporarily, but that's about it.
Yeah, I mean, it's different. Like if I ask you on an atomic level, what's the difference between a living person and a dead person? You can't look at my atoms and see a difference, right? If you just turn the electrical activity off in my brain, maybe for just 3 minutes or so, uh that's it. This body is dead. Same number of atoms, same configuration of atoms, all that same stuff, but that part of me that I recognize as me would cease to be. And I think that the living version of myself is inherently infinitely more valuable than the non-living version of myself. Um, and if I think that for myself, you know, I don't have proof of it, but I feel like I should treat everyone else that way as well.
Yeah, I agree for sure. And I would say that is because you know from firsthand experience that you're not just atoms. You're a self. You're again a self-conscious, rational being that can have hopes about the future, that can develop, that can evolve. Hopefully, not degrade. Although in principle, that's possible for individuals too. And yet, that presupposes um, a reality that is suprasensible, meaning that is not susceptible simply to the eyes or to the nose or to the ears or to the taste buds, right? That's a subjective firsthand reality, and that is not uh, um, reducible to the terms and the equations of physics. And if we do grant that, then that certainly, I think, provides the basis of all of those good things, such as love and kindness and empathy and justice, because I feel myself to be a substantial reality, again, a self conscious being. And if I grant that, if I see that in you, how can I not care for you and want you to be all that you can be? Right? And want you to grow to your full human stature and commune with other individuals on terms of love and justice. Right. But again, I think that, right. But I think that that view is at odds with a particular strand of, again, whatever we would call it, scientific realism, this or that, that would look to the universe and would look to matter as the final and ultimate explanation of reality.
I'm not convinced either way that matter is or isn't the underlying driving force behind all of existence, right? I don't know. I can't tell you how, this combination of electric and chemical activity in my brain, in my nervous system, in my body, how that all adds up to make what I experience as me. I don't know whether it is 100% materialistic or part materialistic and part something that isn't materialistic, that isn't part of our material universe. Uh, but I know what I feel, and I know that like internally, I just can't imagine treating anyone else like they didn't have the same value to their existence that I have to mine. So it's funny, I came in here expecting that this would be a conversation about physics and maybe about physics and philosophy, and instead I find that we've spent most of our time talking about kindness to others and recognition of value, and that's actually incredibly worthwhile to me.
Yeah, yeah. I thought you were going to say, and we should get rid of that. But no, I agree, and and it's interesting how one thing transitions to the other. right? And I think that we may do well to strive for a consistent worldview, right? If I'm unwilling to compromise on humanity, right, and on treating other people as human beings that have value in and of their own self and for their own sake, then I think we need to strive for a broader picture of reality per our intellectual capacities that does justice to that. And I just
Yeah,
think that with
and also remember who the burden of proof is on, right? That if you are arguing, I'm the only one who exists, the burden of proof is on you to prove that you're the only one who exists. And if you're arguing you're the only one who matters, it's on you to prove you're the only one who matters. The de facto assumption has to be we all have value.
I think so, right? But again, I think that to be consistent, then we need to say we need to strive for a vision of reality that does not end with some of simply the things we've been taught in textbooks or the latest theory of the latest milieu, whether it's the Aristotelian worldview that was for centuries considered to be absolute reality, right? There's an astronomer at I think the University of Padua, if I'm not mistaken, somewhere, and he refused to look through a telescope when he thought that what he may say may contradict Aristotle. He's like, it cannot be Aristotle.
Yeah.
That's it. All right, so now we have the same attitude all across the world, probably due to the way that things are taught in school. That the absolute reality is atoms, and the absolute reality are the universe and the stars and the chemicals and the neurochemicals and so forth. But that doesn't mean it is the absolute reality. And we can start with ourselves and with the imperative of our growth towards the good. We can start from there and then kind of leave the status of the empirical world, right, kind of as up in the air. Right? But most of all, what's essential is that we develop and we overcome our selfishness and we attain to the human good, right? One and all and all
Yeah.
in one.
And I think you'd be hard pressed to find a scientist who thinks that what we understand about what we call physical reality today is the final answer, that we'll never learn anything new and fundamental about existence because there's nothing more to learn. I think you'd be hard pressed to find a scientist who thinks that. And if you're a scientist who doesn't think that, I think you have to keep your mind open to the possibility that reality is far richer and weirder than anything we've imagined so far.
Yeah. No, that's a great point, man. Yeah, I think we should keep our mind open. And there's an ancient saying from the Greeks, I believe, the Greek philosophers, that we can start from the road down and go up, but we can't start from the road up and go down. Meaning, if we try to, first of all, before I ever make one single move concerning my human development and such, I need a perfectly clear picture of reality. I need to know everything. I'm never going to get anywhere, right? Because on the contrary, if I start with the facts on the ground, with myself as I am, right? For example, I acknowledge my own psychology. I acknowledge my own issues. I acknowledge my own selfishness, and then I take small steps to move in a more positive direction. We can move up, starting from the bottom, right? So to your point, if we try to start from the top and we say, first of all, we need the theory of everything, and we need to know the dark energy and the matter, and whether it's radiation or the Big Bang, and then I'm gonna think about myself. We may never
Yeah.
get there. So we start
Yeah,
with
you
where we
can't
can
you
start.
can't start from where you wish you were. You can only start from where you are.
Right. All right. Well, I really appreciate it. Are there any other topics that you would like to touch upon, Dr. Siegel?
Jeremy, thank you for having me. I think this was a fun conversation, and I hope it's a treat for your listeners too.
Absolutely. It was a pleasure. You had a lot of very interesting points, and I'm sure it'll be fascinating to anybody that tunes in.
All right. Well, thank you very much. Have a wonderful evening, and we'll be in touch.
Thank you. You as well.